deleteDigit. Is everyone ready? Let's dive in. Okay, so in this task, we're given some integer, so like a whole number, maybe negative, maybe positive. I think in this case it's going to be positive, but we want to find the maximal number you can obtain by deleting exactly one digit in the number. Okay, so that's not exactly a mathematical operation, but basically what we mean is we're just getting rid of one of the digits, pretending it's not there whatsoever, and we're just trying to find the biggest possible number. So, for example, if we're looking at 152, so number 152, let's write that down in kind of a cool color here. So we'll say 1, 5, 2. Okay, so if we're deleting exactly one digit from this, then we basically have three possibilities. We could delete the 1, which would give us 52. We could delete the 5, which would give us 12. There we go, 12. Or we could delete the 2, which would give us 15. So we say, okay, well, between 52, 12, and 15, the biggest number is 52. So I guess we're going to delete the 1. Okay, cool. But what is it that we actually want to return here? Is it the 1? Is it the index of it? Is it the result, the 52? It's the 52. Okay, so we want to actually give the result that was the biggest after we delete one digit, after we get rid of one of the digits here. Okay, so one last thing to note is I did mention before, it's an integer. Technically, an integer means it could be negative or positive, but in this case, it's going to be positive, and specifically, it's going to be at least 10. So it's going to be at least a 2-digit number, which makes sense because otherwise, not that interesting. You know, if we just have one digit, then well, there's not going to be anything left over after we delete the digit. So, okay, great. Let's get started. I think our game plan is basically going to be to start with a brute force solution. Okay, so our brute force algorithm is basically going to be find all the numbers that you could get by deleting a digit. Right, and then after we do that, find the biggest one. Okay, that's pretty much it. So I guess I'll say something like this. Let numbers be assigned the value of, no, not 0. Let numbers be an empty array. And then we want to do a loop on this. We want to say, okay, here's what we're going to do as well. I'm going to make a constant here, and it's going to be called num, and it's going to be n.toString. And you might be looking at that and thinking, well, it's a little weird that you're calling that num when really it's a string. And yeah, I realize that. That is a good point. I thought about maybe calling it like str for string or something like that, but the thing is, I feel like that would be equally misleading because it is a string containing a number. It's a string representation of a number, and we're just working with it as a string for now, just for ease of use, basically. That's that's the idea. So, okay. From here, what do we want to do? Well, basically we want to loop through. We want to say for let I be assigned the value of 0. I is less than, I guess, num.length and I++. We basically just want to go through to every character of this number. And then we'll say let new num. We could call it something different, but basically this is the number that we're going to get after we delete that one digit. So new num is basically going to be, well, okay. We might be looking at this and thinking, I want to use a splice. You know, splice is something that we can use, and it's just going to get rid of a single character, and or, well, really, however many we want, but it's really the thing that we naturally would use if we wanted to take out one character and make no other changes to an array. And that's the thing, we don't have an array here, we have a string. So we're not going to use splice, or at least we're not going to use it yet. Maybe we'll take a look at how to do that later, but for now, what we're going to use is slice. So we'll say num.slice, and this is going to be the part to the left of the character. So like, for example, let's say we were looking at this one, this 1001, right? So let's get kind of a gold, like a buttery gold. That would be a good color. Yeah, okay, so 1001. Great. And now basically the idea is, let's say we're deleting this character right here. Okay, so that means the remainder is going to happen in two parts. So we've got this part over here and then this part over here, which is just one character, but it might not necessarily be depending on the case we're looking at. So over here, this part is going to be num.slice. It's going to be the slice that goes from 0, like right from the beginning, all the way up to and not including this character at I. Okay, so the character at I is this one right here. So it's not going to include that. So this part would be sort of like num.slice with an argument that goes from 0 to I. Okay, and then the next part over here, this is the part that starts at index I plus 1 and then goes all the way to the end of the string. So we'll just do .slice with I plus 1 as an argument. We don't need a second argument because it's not going to end before the end of the string. Okay, so .slice, I think we said this, right? And then we're going to concatenate that with num.slice I plus 1, and that's it. So that's our new num. And we'll do numbers.push. We'll put new num in there. Yeah, great. And then at the end here, for now, let's just say return numbers. I want to know what it looks like. And there we go. So we've got our 52, we've got our 12, we've got our 15. There's just one issue here, and it's the fact that these are strings. So let's make them not strings. I guess if we're calling this new num, we might as well go ahead and do a parse int on this. Wrap it all up. There we go. And now when we run this, we're finding that our array contains not the strings, but the actual numerical versions of these results that we're looking for. Okay, cool. So we're returning numbers, looks good. What we want actually though is just the 52. So yeah, let's get the 52. It's not actually going to be that difficult. All we need is a math.max, except it's not going to work if we just do it like this, because now it's just going to take in, it's going to say, well, there's only one thing here, and it's an array. How can I even tell what it means for an array to be, a maximum? So it's saying null. This doesn't make any sense. What we wanted actually was for it to check the 52, the 12, and the 15. So we're going to spread it. We're going to say, I don't want you to look at the array itself. I want you to look at what's in the array. It's what's inside that counts. And so we're giving it a spread operator. There we go. We're getting the 52 in that case. We're getting the 101 in this case. We're getting, it looks like, what we're looking for. So let's run this. Oh, yeah. Okay, that is what we're looking for. And we have just completed the rainbow of clarity, which, that's nice. Feels good. Okay, so, now it feels even better. Okay, you gotta love that 10,000 coin. Okay, so, nice job. We've completed this one. It's working. But really, this is very much a brute force algorithm. This one is going through, it's looking at every single one of our possibilities here. And the thing is, well, in this case, the number can only be as big as 10 to the 6. You know, what I really would have liked in this challenge is if they had made it such that the number is a string to begin with, so that we could make it a lot bigger. And then we could make the length make it length 10,000 or something like that, make it a huge number so that this brute force algorithm would actually be like, oh, I'm timing out. Although you'd have to make it pretty damn big for that to happen, but still, that'd be fun. That would enrich the problem. So yeah, I mean, in this case, we're going to have at most 6 digits, right? So this, I mean, it can loop 6 times. It could loop way more times than that. It's not going to make much of a difference. So we don't really need to worry about the inefficiency of this algorithm for this particular case. But I would advise you to sort of, keep time complexity, space complexity, efficiency, keep these things in the back of your mind at all times, regardless, because, you're never gonna encounter a situation where someone's like, oh, hey, you did a really nice job on that code, but could you make it less efficient? It's just, the time complexity is too good, and we want it to be taking a longer time for bigger inputs. You're just not going to meet someone who says that. So in general, we want to make stuff more efficient. It's, it's our goal for the most part. I mean, the only time when we might not is if it's a case where we really need to prioritize like human readability or something like that, if it's a really educational example. But for the most part, yeah, we want to prioritize the efficiency of the algorithm. Okay, so because of that, let's think about this. Let's actually take a moment to think about like what kinds of values are going to be the winner here, right? Like, why is it that we deleted the 1 and not some other number here? Why was that? Why is it that we deleted one of the zeros in this case? Why is it that we'd want to delete the 0 over here? Why is it that we want to delete the 1 in this case? And they all sort of have something in common. The idea is that in order to make the number bigger, we need to consider what happens when we delete it. So in this case, when we delete the 1, it's kind of getting replaced by the 9 that comes after it. Like if we deleted one of the 2's instead, then effectively this would be a 1 instead of a 2, so that's just going to be a smaller number. If we deleted one of these 2's, same thing, it's not going to look any different than what I was just describing, having a 1 over here. So basically, the idea is that we need to make sure that when we delete that number, it's basically going to be replaced with something bigger, if possible. So like, for example, if we look at this second one over here, well, we start with a 1. Would we want to delete that? No, because then it's going to get replaced with a 0, which is not bigger. Do we want to delete this 0 right here? Well, maybe. It's not going to make much of a difference because there's just another 0 after it. But if we look at this one, if we delete this 0, the next number is a 1. That is bigger than the 0. So that's good. That's what we want. If we look at this one, we deleted the 1 because it gets replaced by a bigger number afterwards. It's the 5. Whereas if we had deleted the 5, no, we'd get replaced with a 2. That's no good. We replace the 2. No, also no good. It doesn't have a bigger number after it. The point is, we want to delete the number that either has a bigger number after it or it has no number after it. Okay, so if we can't find one that has a bigger number after it, we'll just choose the one with no number after it. So that's essentially what we want to do for this one. So we're going to start out the same way. We'll say constant number, or num, is going to be n.toString. And if it's bothering you, you can call it something else. Call it string or even num string if maybe that's the best way to do it. But the point is, we're going to do a loop, but our loop is going to be a little more efficient. Okay, so what we're not doing this time is creating a new number each time. What we are doing in this case is we're basically going to say, well, is there a bigger number after you? So we'll say if num at I is strictly less than num at I plus 1. Okay, so under that case, or under that condition, that's when we want to say, oh, okay, so let new num be assigned the value of num.slice. Same stuff we were doing before, from 0 to I. I mean, this is basically, watch out for case sensitivity. This is basically like we reach this point and we say, okay, this is the 1, instead of just like testing every single one of them and then finding the maximum at the end. We're just going to go ahead and return this one. There's just one problem, and let's run it to find out what that problem is. What about this case? It's giving us null, and I'm actually surprised it didn't have more of an issue with that because of the fact that we're doing this. We're saying num at I plus 1. Oh, okay, I understand why it didn't have an issue. It's because num at I plus 1 in that case would be undefined. We get to this point where I is already 1, I plus 1 would be 2. There is no index 2 for this number here. So we sort of need to check that. We'll say, well, yeah, either if that's the case or if I happens to be at the end already. So if it's already num.length minus 1, or if it's this. Okay, and yeah, okay, cool. Part of the reason I wanted to put this one first is because if this ends up being true, it's not going to bother checking the next part. And that's good. Because there would be no num at I plus 1. So that kind of saves us a little bit. So let's run that, and oh, very nice. That's working. Is it passing all the hidden tests? You bet it is. Okay, so again, the reason I like this one better is because even if the problem had been formulated in such a way that we were given a string number, which I mean, that's like the first thing we're converting it to right off the bat, even if we were given a string number with a super long length, like, 100,000 characters long, this one I think would be doing a better job than this one down here because it's not doing all this string business each time. I mean, if we're doing a slice, I have to imagine that's the sort of thing that's going to scale up with our time complexity, like in the sense that if our input was very large, I think it would take a longer time to take a slice of that input, especially, you know, like considering that this slice goes all the way to the end of the string. So I think time complexity wise, I think we are safer with this one. I think this one is better because it's not doing this every time. It's only doing it once, and it's when it knows that it's the right time to do it. Okay, so there's just one more thing I wanted to talk about with this, and it's this idea of using splice, because we sort of mentioned splice before, and we said, well, we can't really use splice because we're not talking about an array. We're talking about a string. So let's talk about an array. So we'll make this an array. So now, and that's my favorite way to turn a string into an array. Basically, the idea is that, okay, well, I'm going to modify this in just a sec, but the idea is that we're saying the ... here is spreading all the characters from this string. They happen to be digits. So we're taking all the digits out of this string, and we're inputting every single one of them into this new array, and I'm using an array literal for that. So yeah, that's a nice way to convert a string to an array. And we'll just call this, I guess, like digits for now. Yeah, we'll just call it digits for now, because it's not really a number anymore. It's a set of digits. Okay, and then for new num, we'll say, instead of this business over here, we'll just do this. We'll say digits.splice. Now keep in mind, this is a mutating method. It's a destructive method. Like when we do splice, I don't have to say like digits is a sign of it. Like, you know, I don't need to do this or anything, because the point is splice actually modifies digits. It will change the array. You know, digits on the line before this is not going to be the same as digits on the line after this. That's all I'm trying to say. So, dot splice, what are we splicing? Well, we're splicing the stuff that begins at character with index I, or at the element with index I, and it's going to be one element long, and we're not going to replace it with anything, so I'm not going to put in a third argument. I'm just going to do this, digits.splice I1, done. And then new num, this is going to make things a little easier. It's just going to be digits.join. We're basically taking this array of digits, we've taken out one of those digits, and now we're going to join it back into a string. And you know, the fact that we're calling this new num, it's kind of bugging me a little bit because it is a string. But anyway, let's run this. And oh, num is not defined. So where are we talking about num? Oh yeah, when we talk about its length. And a whole bunch of other places, I guess. So digits, 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 digits. Okay, and now let's run that. Great, that's working just as well. Or, well, is it just as well? I don't know. It feels a little silly to me that we actually convert it to an array first. So I guess that's really up to you. But one thing I'm going to do is I'm not going to bother with this new num thing. I'm actually just going to say return and then parse int of this. Parse int, yeah, and we'll get rid of that. We'll run this. Still working? It's still working. Okay, cool. So I'm going to take all this stuff. I'm going to just copy that because it's different enough from what we had before that I want to do like a billion undos and get this back to this point. And that's where it was running, I think. Yeah, it was passing all the tests. So that's basically our more efficient method that uses a string, and then this is that same more efficient method, but now we're doing it with an array. So just, you know, it's a little different, some variety, a little bit of the old spice of life in here. Okay, cool. So was that working? Was that passing all the hiddens? Yeah, nice. Okay, good. So I like that. I'm not sure which one's my favorite. Maybe this one, maybe the string one. I don't know. Anyone else have any favorites? Let me know. You can let me know in the comments, I guess. Anyway, as for now, we just submitted this, so I think we're good for this one. I guess we'll, let's move on from here. There's